We're going to talk about the trigonometric functions of real numbers. So we're going to go back and we're going to redefine our 6 trigonometric functions in terms of something other than opposite, adjacent, and hypotenuse. So on a circle, remember you have something called standard position, which is your terminal or your ray that lies along the positive x-axis. Or it's called standard or initial position. Then your terminal ray is your ray that you end with, and the angle between the initial ray and the terminal ray is the angle in which you're finding the 6 trigonometric functions of. Well, if I drop a perpendicular from the point where the terminal ray hits the unit circle down to the x-axis and make a little right triangle here, and the unit circle is a circle whose radius is 1, that means the hypotenuse of this triangle is 1. The side that lies along the x-axis is x, and the side that is parallel to the y-axis is y. So now I could say that the sine of angle T is y over 1, because sine is opposite over hypotenuse. And its reciprocal is cosecant. The cosine of angle T is your adjacent over hypotenuse, or x over 1. So its reciprocal is secant. The tangent is your opposite over adjacent, and your cotangent must be its reciprocal. These are called the circular functions, because we're talking about trigonometric functions with respect to the unit circle. Let's find the 6 trigonometric functions of each of these given real number t. So let's start with t is equal to pi over 3. Well, first of all, let's remember that pi over 3 is the same thing as 60 degrees. So if I were to draw a picture here in the unit circle, 60 degrees would be up here somewhere. You'd drop a perpendicular, so you'd have a 30, 60, 90 triangle. And if that is your 60-degree angle, then the side opposite 60 degrees is the square root of 3. The side opposite 30 is 1, and the hypotenuse is 2. So the 6 trigonometric functions are going to be the sine of pi over 3 is equal to square root of 3 over 2, because that's your opposite over hypotenuse. So your cosecant must be 2 over the square root of 3. Your cosine is going to be adjacent over hypotenuse, and its reciprocal is secant. And the tangent is going to be opposite over adjacent, and cotangent is its reciprocal. And remember I said for the purposes of pre-calculus, we no longer care if there's a radical in the denominator. It is acceptable for you to leave that answer there. All right, let's do this again for pi over 2. Pi over 2 is the equivalent of 90 degrees. Well, 90 degrees is right here. Remember that the point where the terminal ray hits the unit circle is the ordered pair cosine theta, comma sine theta. So I already know that the sine of pi over 2 is 1. So its reciprocal is 1, because when you flip 1 over 1, you get 1 over 1. Here's the fun part. The cosine is the x-coordinate, which is 0. But what happens when you flip the fraction 0 over 1? You get 1 over 0. Can you have 0 in the denominator of a fraction? No. So we say that the secant is undefined. I know I'm starting to run out of space here. And then the tangent of pi over 2, another definition of tangent is sine divided by cosine. Well, if you know the point where the terminal ray hits the unit circle, you know sine and cosine. So the sine is 1 and the cosine is 0. Wait a second. 1 over 0, that is undefined. But its reciprocal is going to be 0 over 1. 0 divided by 1 is defined. It's 0. One of the things we found out was that if you know the sine, cosine, and tangent of your special right triangles, your 30, 60, and 45, then you're going to be able to find the sine, cosine, and tangent of most other angles in the coordinate plane, because the ones we're going to be dealing with right now all have a reference angle of 30, 60, or 45. The problem is that, depending on what quadrant you're in, the answer could be positive or negative. So here's the way it works. In quadrant 1, all of the trig functions are positive. In quadrant 2, only sine is positive. The other two are negative. In quadrant 3, tangent is positive, and the other two are negative. And in quadrant 4, cosine is positive, and the other two are negative. Now remember that if you have, you may be looking at this going, well, what about secant, cosecant, cotangent? Well, remember the reciprocal of a positive number is positive. The reciprocal of a negative number is negative. So wherever sine is positive, so will cosecant be. Wherever a tangent is positive, cotangent will also be positive. And wherever cosine is positive, secant will be positive. There's a cute little mnemonic for remembering which quadrants you have your positive functions. And it's all students take calculus. And as long as you start in quadrant 1 and then go 1, 2, 3, and 4, you'll be fine. And you'll see in your textbook, this is actually on page 380, which was really cute because I had actually first heard this mnemonic in a lecture at a math conference a few years ago, and I've been using it ever since. So it's a great way to remember which quadrants have positive functions. So let's go find the value of each of these trig expressions. I'm going to find the cosine of 2 pi over 3. Well, first of all, I'd like to know what the reference angle is. And the reference angle is pi over 3. So if you know the reference angle, then you're going to know the point where the graph hits the x-axis. It's going to be 1/2 comma radical 3 over 2. If you memorized this. So we want to find the cosine. In that order pair, which one's the cosine? Well, it's the first value. So I know the answer's got to be 1/2 or negative 1/2, depending on what quadrant it's in. Well, what quadrant is 2 pi over 3 in? Well, you have two ways of doing this. You can either think about the pattern of how radian measures move around the unit circle, or you could just change 2 pi over 3 back into degrees. And degrees are a little bit easier to work with. So if you do 2 times 180 and you divide it by 3, you're going to find out that it's 120 degrees. Well, 120 degrees is in quadrant 2. In quadrant 2, are cosines positive or negative? Well, if you look back at your all students take calculus, quadrant 2, only sine is positive, which means that the answer here must be negative. All right, let's move to part B. I want to find the tangent of negative pi over 3. This one's pretty easy. Remember, if your angle's negative, you start in initial position and you work clockwise. So negative pi over 3, I know, is going to be in quadrant 4. The other thing is that the reference angle is pi over 3. I know from the previous problem that pi over 3 hits the unit circle at this ordered pair. And I just told you guys a moment ago that tangent can be found by doing sine over cosine. I know the sine is square root of 3 over 2, and I know the cosine is 1/2. Square root of 3 over 2 divided by 1/2 is just the square root of 3. But now I've got to ask one last question. In quadrant 4, is tangent positive or negative? So I come back here and I go, in quadrant 4, tangent must be negative. So the answer has to be negative square root of 3. Now let's go to C, the sine of 19 pi over 4. Well, I know its reference angle is pi over 4. So I know where it hits the unit circle. It's radical 2 over 2, radical 2 over 2, or 1 over radical 2, 1 over radical 2. But I need to figure out what quadrant 19 pi over 4 is in. So you can do this in one of two ways. You can either go around the circle and try to figure out where it is. I know that this is bigger than 360 degrees because 360 degrees would be 8 pi over 4. 720 degrees would be 16 pi over 4. But you could probably just change this into degrees and work your way backwards, or you can do your subtracting of 2 pi until you got an answer that's actually between 0 and 2 pi. So 19 pi over 4 minus 2 pi is going to be 19 pi over 4 minus 8 pi over 4, which is 11 pi over 4. So I got to subtract 2 pi again. So 11 pi over 4 minus 8 pi over 4 is going to be 3 pi over 4. And 3 pi over 4 is in quadrant 2. In quadrant 2, are signs positive or negative? Well, I go back over here and I go, hey, signs are positive, so the answer must be positive square root of 2 over 2. Now, what if I wanted you to evaluate trig functions on your calculator using the trig functions? But your calculator only has sine, cosine, and tangent. How are you going to be able to use your calculator to find secant, cosecant, cotangent? Well, these are called reciprocal functions. The cosecant of an angle you can find by just doing 1 divided by the sine of the angle. The secant you can find by doing 1 over the cosine of the angle. And the cotangent you can find by doing 1 over the tangent. All right, now this is where it becomes important to determine if you need your calculator to be set in degrees or radians. If you are performing an operation where you are physically using the sine, cosine, or tangent button, if your angle is in degrees, you need to be in degree mode. If your angle is in radians, you need to be in radian mode. How can you tell the difference? Well, first of all, you already know if you see something with a pi, like pi over 3, you know that's radians. If you see something like 60 degrees because you see the little degree symbol, you know it's degrees. Well, in this next example, I'll call it example 3a, I want to find the sine of 2.2. Is 2.2 radians or degrees? Do you see the degree symbol? Then it's in radians. So you need to change your calculator to be in radian mode by pressing the mode button and then finding where it says radian and degree and making sure that radian is highlighted, and then plug this into your calculator. So in A, when you plug it into your calculator and you do sine 2.2 in radian mode, you should get 0.808496. If you get this, you did it right. For the cosine of 1.1, as long as you're in radian mode, you should get 0.453596. To find the cotangent, you're going to have to do 1 over the tangent of 28. So just do 1 divided by the tangent of 28, and you should get negative 3.553286. For cosecant, you're going to need to do 1 over the sine of 0.98. And you should get 1.204098. I want to look back at the sine of 60 degrees and the sine of negative 60 degrees. The sine of 60 degrees is square root of 3 over 2 because it occurs in the first quadrant. The sine of negative 60 degrees, because negative 60 degrees is in the fourth quadrant. In the fourth quadrant, if all students take calculus, sine must be negative. So I want you to notice that the sine of negative 60 degrees is the same thing as negative 1 times the sine of 60 degrees. So by definition, the sine of a negative angle is going to be the same as negative 1 times the sine of that angle. Now let's look at cosine. The cosine of 60 degrees is 1/2. the cosine of negative 60 degrees is also 1/2. Because in the fourth quadrant, I don't need to draw that again, in the fourth quadrant I want you to notice that cosines are positive. And in the first quadrant, cosines are positive. So the cosine of a negative angle is the same as just the cosine of that angle. The tangent of, I'll do something easy, the tangent of 45 degrees is 1. And the tangent of negative 45 degrees is negative 1. Because, again, negative 45 is in the fourth quadrant, and in the fourth quadrant, tangents are negative. So the tangent of a negative angle is going to equal negative 1 times the tangent of that angle. These are called even-odd properties. Now, because of the reciprocal functions, what's true about sine must also be true about cosecant. Can't write. Let's try that again. Cosecant. What's true about cosine must be true about secant. And what's true about tangent must be true about about cotangent. So, we're going to use even-odd properties to find the trigonometric functions of each of these values. So remember that the even-odd property said if you take the sine of an angle, it's the same as negative 1 times the sine of that angle. Well, as long as you remember that pi over 6 is 30 degrees, and the sine of 30 degrees is 1/2, you're going to know the answer is negative 1/2. For the cosine of negative pi over 4, remember that the cosine of a negative angle is the same as the cosine of that angle. So the cosine of pi over 4 is square root of 2 over 2, or 1 over the square root of 2. So let's do a little bit of review. We just talked about these things called the reciprocal identities. We said that cosine of an angle was the same as 1 over the sine. Secant of an angle is the same as 1 over the cosine. Cotangent of an angle is the same as 1 over the tangent. We also mentioned that the tangent of an angle was the same as the sine divided by the cosine. So its reciprocal cotangent must be the cosine divided by the sine. There are some other identities that we want you to become familiar with. The first one is the one that tends to periodically show up on the ACT, the other two not so much. They are called the Pythagorean identities. They have to do with identities formed by using the Pythagorean theorem. I'm not going to derive them for you. If you would like to see any proof, they are in the textbook. So sine squared t plus cosine squared t is equal to 1. Tangent squared t plus 1 is equal to the secant squared t. And 1 plus cotangent squared t is equal to cosecant squared t. Let's do an example. I'm going to show you two ways of going about doing this. If the cosine of t is equal to 3/5, and t is in quadrant 4, find the values of all the trigonometric functions at t. Well, one way of doing this problem is, if you know what cosine is, you can find sine by plugging this into that first Pythagorean identity. Now, sine squared t, cosine squared t just says take the value of that trig function and square it. So cosine squared t says take 3/5 and square it. So sine squared t is equal to 9 over 15. Oops, not equal to 9 over 15 plus 9 over 15. Not 15, 25. Let's try that again. Equals 1. And then you would subtract the 9 over 25, and you would get 16 over 25. And then to get sine t, you would square root the other side, because that's how you get rid of a square. So you would get plus or minus 4/5. All right, so which one is it, positive 4/5 or negative 4/5? Well, it's in quadrant 4, and in quadrant 4, if all students take calculus, sine must be negative. So we want sine to be negative 4/5. So the sine is negative 4/5, so the cosecant is negative 5/4. We already know that the cosine is 3 over 5, so the secant is 5 over 3. The tangent is going to be sine over cosine, which is negative 4/3. So the cotangent must be negative 3/4. So again, remember, notice that the only values in the 6 trig functions that are positive are cosine and its reciprocal. Everything else is negative. That's from your all students take calculus. Now the other way that you could have done this was you could have said, well, if the terminal ray is in quadrant 4, the angle is right here between the terminal ray and the x-axis. The cosine of that angle is 3/5. That's adjacent over hypotenuse, which means that the other side must be 4. Now because this is in quadrant 4, x is positive, but y is negative. So that's, oops, I'm totally messed that up. Let's go back. Let's see. Okay, so this is angle T, this is 3, and this is 5, and this is 4. Ha! And the reason I know it's 4 without using the Pythagorean theorem is because in geometry, we learned about these things called special right triangles, and one of them was a 3, 4, 5 triangle. So this is negative, we said, and now you could find the 6 trig functions. Either way you do this problem works, and you get the same 6 answers. One of the things we're going to learn to do is we're going to learn to work with some of these identities to do some manipulations. I want to write the tangent of t in terms of the cosine of t. That means I want to write the tangent of t is equal to some equation that only has cosines in it. Well, let's start with this. I said that the tangent of t is the sine over the cosine. Well, there's already a denominator of cosine. I wonder what I could do to get rid of sine in the numerator so that it has a cosine in it. Well, one of the Pythagorean identities had a relationship between sine and cosine. Maybe I could solve this equation for sine. By moving the cosine squared to the other side and then square rooting it. Now here's the next thing. When you take a square root, you don't know if it's positive or negative, because a positive squared is positive and a negative squared is positive. But it did tell me it was in quadrant 3. In quadrant 3, are signs positive or negative? They're negative. So it turns out that I want to use negative square root of 1 minus cosine squared t. So now I could rewrite tangent as negative radical 1 minus cosine squared t over cosine t. And now I've written my tangent in terms of cosine.